I'm here to basically share some of our experience with stateful sets, especially when we try to run distributed stateful system like a database on top of stateful sets, right? Like what all challenges we went through, why we had to move away from stateful sets and stuff. So we'll see how that goes. So quick intro about myself. I am Babu Srithar, India Site Lead and Senior Director of Engineering at Cockroach Labs, creator of CockroachDB. It's the distributed SQL database. So the agenda is going to be a quick history of how stateful set came into existence. So what is the problem statement that it is solving in the Kubernetes world, and some of the unique constraints that distributed stateful systems have, and how these two things work well or don't work well. So this is like a legacy application where you have a stateless part of it and then a stateful part of it, where there is an application which is just a HTTP server and then there is a database, right? So before Kubernetes world, it used to be deployed in like two different VMs, like application, the stateless part in one VM and database in another VM and stuff. And just when we needed HA, basically both of the layers were scaled independently. So the application, the stateless part was like replicated independently and front-ended with a load balancer, and then the database itself was scaled independently using a cluster. I mean, every database had its own way of providing high availability data replication and all that stuff. And when the Kubernetes came into picture, initially it started addressing stateless applications or services more and more, and primarily it did not address a lot of stateful applications. So the problem that it posed was, this is where we use deploy, which is a common construct that almost everyone of us would have used while we are trying to do something on the Kubernetes. So the problem that it posed to organizations were like people had to still manage their infrastructure or manage their applications in two different ways, one through Kubernetes, one through something else, right? It also assumed that a lot of the resiliency, high availability, and everything about the data layer will be taken care of by someone else, and it happily worried only about the stateless part of it. And while the community realized this and kept evolving in terms of introducing the PV, the persistent volumes, PVC, storage classes, and all the stuff, still somehow the overall management of the data layer was still offloaded to someone else external to the Kubernetes system. That is when stateful set was introduced, right? So during the stateful, when in 1.5, in Kubernetes 1.5, when stateful set was introduced, it started addressing a lot of these pain points. So it made managing stateful applications almost close to how we would manage a stateless application also, right? It gave a lot of ability to automatically restart things, ability to like monitor and control things. It gave a lot of goodness. It also came with these properties. So the very first property, let's say in a stateless system, let's say Nginx server, right? So though the pod goes down, comes back, you don't care about what identity it was for the pod before, pod after, and all the stuff. But in a stateful system, you do worry about, okay, because every stateful system has some storage, some disk, some volume attached behind it, right? And when a pod goes down and comes back, if it starts connecting to a different volume, then there is going to be a lot of data corruption issues. So that is where a stable pod identity mattered a lot for stateful set. So it came with that, and ordinal index. So apart from just the stable identity, it also gave some predictability in terms of the naming conventions. So let's say if you have 5 pods in your stateful set, it used to start from 0 to 4. So people were still able to code against that so that they could address any of this scale up, scale down challenges. And it came with stable persistent storage connection, reliable connections, and all the stuff. And it also came with some additional goodnesses like ordered deployments and ordered automated upgrades, right? So though it all sounds good in a simple stateful application, it's all useful. So in a normal simple stateful systems, what happened is it made a lot of the problems that I was mentioning pretty easy, right, to manage. It gave a consistent way of solving problems across stateful layer and stateless layer. But it worked very well for simple stateful applications. But in case of distributed stateful systems, The distributed stateful systems, one of the different thing is it handles a lot of data replication by itself, and every distributed stateful systems does this in their own way, right? And that posed a lot of challenges in terms of how a stateful set can come up with the unique properties that will basically satisfy all these requirements, which it could not, right? Like it does not work well in all the different scenarios, in all the different ways in which the vendors are doing. Let's say for an example, Elasticsearch, let's say for an example, Cassandra. So everyone does their replication in their own way. That's why they are specific to the use cases that they are solving also. And that is why stateful set cannot solve all that problem. And it gets even more interesting when you want to solve this at scale, especially when you want to provide this as a self-serviceable system. It gets even more trickier, right? So this is where we will talk about CockroachDB, because that is what I am familiar with, at least in terms of a distributed stateful system. So CockroachDB, just to give an idea, it's a distributed database. It's an open source, SQL based. It makes the operational aspects very simple for the administrators and the developers. It's also ACID compliant, and it is also location aware. Let's say if you want to, I think in the previous session someone talked about the GDPR compliance and stuff. Some data cannot leave one region to other region and stuff. So instead of having two different clusters or multiple clusters and all the stuff, in CockroachDB you can have one cluster, and you can set your location data placement strategy based on some of the attributes of the table, and it will automatically take care of that. You don't even have to spin up new clusters. So it addresses a lot of these problems. So before going into what all the challenges that we faced, I would like to talk about some fundamental aspects of CockroachDB. That is, only then we will be able to make sense of like why those challenges are raised. So under the hood, CockroachDB stores everything as key value pair. So a table like this, by the way, these are some of the dogs that came into our office. Some of our co-workers brought into our office. So all our examples will follow this. So like any table like this, on the storage layer, it gets represented like this as a key value pair. So overall, we have at a very fundamental level, we have two important things to understand. One is ranges, the other one is raft. So ranges are nothing but our blocks, or like by default it's 512 MB, but it is configurable based on the use cases. So a long key space like this will be broken down into multiple ranges like this, like in the picture. And what we do is we use raft as a protocol to replicate our data. Raft gives us the ability to write consistently across different nodes when we want to do that, right? So, and we don't treat the entire cluster as a raft cluster, right? We treat each of these ranges as a mini raft group or mini cluster for ourselves, so that we don't know like which range set is going to be placed on which node and stuff, right? So it gets totally distributed, and the distribution is taken care of based on multiple different attributes like load, scale, the factors like user-defined attributes and things like that. And like I said, each range is a raft group for us. So if you see here, one of the differences between a normal stateful system versus this is, normal stateful system, it worries about where the data is put, and probably it also relies on the underlying infrastructure's ability to replicate data. But CockroachDB has a lot of intelligence to do very powerful data replication in terms of like where to place, how to distribute, when to load balance, and all that stuff. So now, before going into the challenges, so how the CockroachDB constructs map to Kubernetes constructs, right? So each node of CockroachDB is deployed as a pod on the Kubernetes cluster, and we use PBs and PBCs to manage our storages. And a single CockroachDB cluster can span across multiple Kubernetes clusters. So I mean, like you will have an operator which is local to a Kubernetes cluster, but once the Cockroach nodes comes up at the CockroachDB cluster level, you can even add nodes from other different clusters, right? And in a high performance environment or in a high performance requirement scenario, we advise to use local storage so that the IO ops and all are taken care of. And in fact, we suggest to disable any storage level replication, because that might add to performance overhead, because we are already replicating and then the storage will also replicate. So the requirement that we had at hand was we had to host CockroachDB as a service, right? So today, like everything has to be consumed as a service. That's what people like also. So it has to go across different clouds, and we wanted to standardize the operational aspects. We did not want to have one per cloud and all the stuff, and we also had to build this service in a way that it can survive it can be a zonal zonal survivability mode, which means even in even if a single AZ goes inside a zone, even if a single AZ goes inside a region, we will be able to still survive other. We will be able to survive without degrading our services. So how did we operate even with Statefulset? Like how did we get started with Statefulset? How did we operate, right? So Statefulset, like I said, it gave some ordinal guarantees in terms of how the node will be restarted when you update, basically what it does is it goes in a reverse order. Let's say when you want to restart node 2 in a 5 node scenario, it will go and restart node 5, node 4, node 3 and then node 2. So it gave some things, some ordinal guarantee like that. So what we did is we relied on that. So we went and like carefully restarted some of our nodes to ensure that we follow the Statefulsets. We leverage the Statefulsets guarantees, and it worked okay. And we also applied some partition upgrade strategy to ensure that okay, we only we carefully choose which node to be upgraded and all that stuff. And when we wanted to upgrade the Kubernetes version itself, we followed immutable infrastructure practice, where we used to bring in new nodes of Kubernetes, and we used to drain the old nodes. We did not want to like go and edit things, right? And it worked well till we had a small number of clusters, small number of nodes, like pets we used to call, right? And then when we wanted to really scale, it did not work so well for us. So this is where we thought we need to write our own operator. We need to move away from Statefulset. So what we did is, I mean, like the built-in constructs took us so far, but not very far. We also needed more control to ease our operations for our operational team. And also, like I said, CockroachDB as an engine, it has a lot of power in terms of data resiliency, the ability to restart nodes faster. It can even survive a lot of, it can even survive a lot of restarts at a time and things like that. So we wanted to leverage all of these capabilities, but with all the restrictions that were imposed by Statefulset in terms of ordinal guarantees and all the stuff, we were not able to. So this is, again, like we introduced a custom operator and we defined two custom resources. So one is CockroachDB cluster and the other one is CockroachDB node. So the CockroachDB cluster, it used to take care of, it used to be the replication controller, and it used to be aware of all the topologies and stuff. And CockroachDB node, it's a level above the low-level resources like pods and PBCs. So it gave us the control on like how these pods are going to restart. It gave us the control over how these PBCs are going to be linked and stuff. Again, like another thing that we wanted to take control was about rolling updates. So when the rolling update triggered, so typically it goes through multiple, it just goes and updates all the different parts, basically CockroachDB nodes, right? We wanted to have control over that. So essentially, once we had control over that, we did a restart instead of upgrade, and during the restart, the before start, after start, and using the life cycle hooks, we were able to control when certain nodes have to be upgraded, when certain nodes should not be upgraded and stuff. Okay, now we will go through the challenges quickly and see like how some of these operators and custom resources helped us solve this, right? So surgical updates. So what happens is, let's say in case of a 5 node scenario, we found something happening with pod 2 or the node 2 in Cockroach terminology, right? So what we wanted, so we were not able to go and just update that. Because of Statefulsets ordinal guarantee, we had to go restart pod 5, pod 4, pod 3 and stuff. So which is like in a 5 node, probably it sounds okay, but when it goes to like tens or even hundreds of nodes, it becomes very tricky to do that, right? and it introduces a lot of system instability. So this is where like once we moved away from stateful set, and once we had control over all the resources, we were able to go and surgically update some of these nodes that we wanted to update. The second thing is ordinal reuse. Again, in stateful set, there is a ordinal predictability. Because of that, they always reassigned some of these ordinals. Let's say you scale from 4 node to 5 node and back to 4 nodes, or like 5 to 4 and then back to 5. What happens is there is a possibility that 5 gets reassigned to the node again, right? So in that scenario, just in case if the PV was not completely disconnected, there is a possibility that the same PV will be picked up again by the new node, and that causes even data corruption scenario, right? We proactively detect such scenarios, like any resource that gets decommissioned from our cluster, and when it comes back to cluster again, we even panic. We don't accept those resources, right? So this was though it was not like a very prominent issue, but theoretically it happened, and it's bound to happen, right? So we would experience. I mean, this is something that we experienced, and we wanted to take control of this. So again, though we leverage a lot of goodness about stateful set, but one of the tweaks that we did here is, instead of going by the sequential ordinal IDs, we went with random UID. That helped us avoid reattaching the same PVs again to the same node. So pod disruption budget. So in Kubernetes, there is a feature called pod disruption budget, if you do not know. So basically, for any voluntary disruptions like updates, rebalancing, reconciliation, anything like that, you can still go and specify what percentage of your cluster can go down and things like that. So that is what is called the pod disruption budget. And the stateful sets do not live, and what is advised to, so basically Kubernetes says that any of these operators and things like that, it has to leverage eviction API so that it can honor this pod distribution budgets that were declared as part of the resource. But stateful set do not honor that, at least from the code discovery that we got recently. And there is a possibility that it would violate PDB in certain cases. And we cannot afford to have PDB violations because we relied on that. And this is another thing that we wanted to take control over. And having our resources tracked independently, having our own operator helped us solve this also. Required homogeneity. Required homogeneity, again, stateful set required all your pods to come from the same image, same bits and everything like that. In case of, so though it works great for other applications, in case of CockroachDB, we wanted, one of the examples is like we wanted each of the nodes to have their own certificates associated with their own domain names, right? So that we don't want to compromise on the security aspect. So if we were to do this with stateful set, we would have to either open up some more permissions for the pods itself, so that when they come up, they could just go and like mint their own certificates, or we could have done some other workaround, but at a scale, it becomes a problem. That is where operator with its own lifecycle hooks helped us to take control over things like this without compromising on the blast radius. Immutable fields. So this is another one of the example, like PV spec in the stateful set cannot be deleted without deleting and recreating, cannot be modified without deleting and recreating the entire stateful set, which was not ideal for us. So we had to go keep changing storages, like upsize, downsize storage capacity and things like that. This did not work very well for our use case. Again, we had to take control over. This is one other reason why we had to take control over how all these things is managed. Overall conclusion, so if you see, stateful sets are great for like normal or simple stateful applications, but when it gets little involved in terms of how the system itself treats data differently, how the system itself wants to maintain its life cycle, then you will like sooner or later run into the issues. So probably if you are doing something like this, it's better to think about. That's about it. So thanks for the organizers, and credits to the fellow roaches who helped in either creating the document, reviewing, working on the original content itself. Chris, David, Lisa, Steve, Yandu, and DA. So cockroach as a species, it can even survive nuclear bombs, right? So when our founder started the company, they wanted to build something that can withstand disasters. So that's why they came up with this name. And one another reason is like many people ask us like this. That is also another reason. So it makes people very curious. Why this name? What is this? And all this. Yeah. So you are talking about PDB in general. So stateful set has to first honor the eviction API and check whatever the parts are, whatever the APIs are telling it to do. Right now, today it does not. That is why we had to take control. So once we took control over it, we were able, because we exposed low-level APIs through our resources, we were able to coordinate better in terms of, okay, are you ready to, let's say in our system, so even though you have the PDB defined, so will we be able to tolerate this kind of disruption is something that we will be able to calculate at our operator level, and that is where we were able to take control over it. So stateful set itself does not take care of it for you. Okay, can we take this offline? Yeah, sure. CockroachDB is an open core database. So the core of the database is open source, and so if you want to take it and host it to something else, there are some licenses and components. But the core, the database itself is.
And Google uses its own true time or that kind of algorithm. So what does CockroachDB use specific for global timestamps across all the nodes?
Yeah, I think again I'll discuss this. Probably it will take a little longer. I'll discuss this after this stage.
Thanks.